Hey physics, I wanted to make a video of the Investigation 5 review for those of you that are in my first and second hours, and then whoever else wants to use it to check up is totally fine too. Okay, so Investigation 5 is about subatomic charges and movement. So first thing we're going to do is label the parts of the element square and the periodic table. So the atomic number, and you can do this either by moving the blocks or by putting these arrows where they go. That's the atomic number. It tells us how many protons there are. This is the atomic mass. And the atomic mass is the number of protons plus neutrons, because they both have an atomic mass unit of 1, or they both have an atomic mass of 1 atomic mass unit. So the element symbol is this Ne. It's kind of hard to see, but you guys saw me make it. Okay, so element name is neon. And the electrons in each valence shell are shown right here. Okay, so with this one, you can use the simulation to build these so you can actually see what's going on here. I will do that with the first one, and then I'll just kind of tell you how I know how to do that without the simulation too. So I'm going to click this link to the simulation. I'm going to click on this one. Okay, now the first one I need to make is neon, the same one we were looking at a second ago. So I happen to know that there's 10 protons. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now this says neon, but I know, because of the atomic mass there, that there's not just 10 protons, but there's also 10 neutrons. So let me do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you want to double check that it is the right number of protons and neutrons, you can say, click the stable versus unstable. And if it's not stable, you'll see it starts to shake like that. Okay, and then I see that it has a neutral charge. So it needs 10 electrons. And these circles are showing the energy level. So you remember that the first energy level fills up first, the one closest to the nucleus, and then the other one fills up next. And then once that one is full, if it's a bigger atom, then you can fill up the next energy level. But as soon as an energy level is full, then those electrons kind of want to stay put. And you'll remember that that very outside energy level is the valence shell that has the electrons that can move, or that will pull other electrons in. So, okay, so there's my neon atom, and it's neutral. I can see that it has a net charge of 0, which means it's neutral, and a mass number of 20, which is just what it should be. So let's go back here. Okay, so we had 10, 10, and 10 for this one. Okay, so for this next one, I'm not going to use the simulation. I'm just going to talk to you about how I knew how to do it just by looking at the square here. So the atomic number of oxygen is 8. That tells me how many protons there are. The atomic mass is almost 16. So 16 minus 8, 8 neutrons. And this one has a -2 charge, which means that it's going to have 2 more electrons, 2 more negative electrons than protons. So 10. Okay, so beryllium has an atomic mass number, or sorry, an atomic number of 4, meaning 4 protons. It has an atomic mass of 9, so remember, the number of neutrons does not always equal the number of protons. It's definitely not a given. You got to check that atomic mass every time. So there's 9 atomic mass units, sorry. And 4, so that's going to be 5 neutrons. And this one has a +2 charge, meaning there's going to be 2 fewer electrons than protons. So that means there's going to be 2. And you'll notice a pattern here, which is that we try to always make these charges that the atoms have match up with what they would really have in real life. And you guys remember that that atoms always want to complete their outer energy level. So you will often find that these atoms will either have 2, end up with 2, or end up with 10, or end up with 18. Like, you're going to complete an energy level with each one of these atoms. So, okay. I will show you what that looks like real quick. Let me just pause. Oops. So I just wanted to show you what I meant by that. So we saw that this beryllium atom has 4 protons and 5 neutrons to give it a mass number of 9. And it had a +2 charge, which means that if it was neutral, it would have the same number of electrons as protons, which would be 4. But, as you guys know from this test, atoms prefer to have a full energy shell more than they prefer to be neutral. So this beryllium atom has 2 electrons, which fills up that energy shell, and then it got rid of the 2 that would have been on this one. So I'll do that visual here too. Okay, so it would have had 4 if it was neutral, but atoms prefer to have a full outer energy level. So if this one is full and this one is empty, then this outer one basically just goes away, and you're just left with this one that's complete. Okay, let's go back here. All right, so sodium has 11 protons, as we can see here. This has an atomic mass of almost 23, so that means it's going to have 12 neutrons, and it has a +2 charge, so it's going to be 2 fewer electrons than protons. So, and this one I actually messed up on. It should have been a +1 charge. I'm going to fix that here. You can fix it, or, yeah. So +1 would give it 10. And that would fill up those 2 energy levels. That's a good way to check yourself. Okay, so fluorine has 9 protons because of that atomic mass number. It has, let's see, this is almost 19, so that means it's going to have 10 neutrons. And how many electrons does it have? It has a -1 charge. So yeah, so it's filled up 2 energy levels. All right, let's keep going. All right, oxygen atom with a -2 charge. Whew. I guess I need to make this send to back. Okay, if ever there's something that's in your way there, if you right-click on it and you say order, you can make it go to the back, and that will make it out of your way. Okay, so this is going to be 8 protons. What just happened? There's 6, 7, and I need to copy and paste one. 8, okay, and then we need neutrons in the middle, so this one has 8 neutrons, 2, 3, 4, 5, 6, 7, 8. And it's going to have 10 electrons. So if you want to show the energy levels here, it's optional, but it's always good to do the best things you know how to do. So there's 2 on the inner energy level, and then there's going to be 8 on this outer one. And there's a certain way you're supposed to fill up these energy levels so that you're showing that they repel the whole time. Okay, I need to copy and paste a couple more. So there's that one, and that one. Okay. Fill in the blanks. Atomic mass comes from the number of protons plus the number of neutrons. Atomic number tells you the number of protons. An ion is just a charged atom, so it has more or fewer electrons than protons. When I hear the word ion, I like to, I almost hear like an electric buzz in my head, like the same feeling you get when you're like petting a cat that's got a lot of static electricity, or when you go down a slide and you feel that like electric crackle. Ion is that electric charge that it has. An isotope has more or fewer neutrons than is common for that atom. For isotopes, I like to remember like fossils, because fossils are identified by the number of isotopes in them. Okay, so you can find out the average number of neutrons in an atom by looking at the atomic mass in the periodic table, or on that element square. Alright, this is actually an investigation 4 thing, but I like this slide, so I put it in. Okay, protons have a +1 charge, and they have an atomic mass unit of 1. It's kind of like acting weird. Okay, neutrons have 0 charge, or a balanced charge, and they are also 1 atomic mass unit. And electrons have a -1 charge. They're super tiny. They are about 5/10,000ths the size of a proton. But you'll see that this is, we'll write it as like 1,000th of the mass of a proton. Okay, boron. Okay, so this has 5 protons. 2, 3, 4, 5. I can see that because I see the 5 right there. Okay, it has almost 11 atomic mass units, so I'm going to put my neutrons in there. So 11 minus 5 is 6. 2, 3, 4, 5, 6. And as always, you can pause me if it's going to take you a second longer. That's totally fine. Okay, and then this one has a +3 charge, meaning that if it was neutral, it would have 5 electrons, since there's 5 protons, but it actually has 3 less electrons than protons. So I can put these here to show that just that first energy level is full. Okay? Explain. Can you give an oxygen atom a positive charge by adding a proton? No, because you really can't add protons. Protons are held in the nucleus by the strong force, so they, they're not going to move out of the nucleus. Let me just pause myself because my time's running short here. I'll write that and I'll come right back. So I said no, because the strong force holds the protons and neutrons in the nucleus, and they're not able to leave for the most part. It takes a lot for what's in a nucleus to change. But when we talk about charge, that's easy to change. We have done so many experiments with charge this semester, and that's a transfer of electrons is what's going on there. Okay, so does changing the number of electrons change the type of atom? No. Changing the number of protons changes the type of atom. Okay. Do atoms always have the same number of neutrons as protons? No. Boron is an example of an atom with more neutrons than protons. And I just grabbed that from one of the other things that we just did a minute ago. Okay. I have about 45 seconds here. So I might need to make a different, I'm definitely going to have to do a second video here. I am going to stop right here and start a new video then, okay?